In this series of lessons, we'll get practice determining the radius and interval of convergence of power series. Our first problem is sum n equals 0 to infinity 2 to the n x to the n. And again, our goal is to determine the radius and the interval of convergence. The first thing we're going to notice here is that this is a power series centered at x is 0. So if we plug in x equals 0, we just get 0. So the center of this power series is x equals 0. So our next step, once we've identified the center, is to use the ratio test. So we take the limit as n goes to infinity, and we look at the absolute value of the n plus first term, so 2 to the n plus 1 x to the n, over the nth term, which in this case is, 2 to the n plus 1 x to the n plus 1 over the nth term, so 2 to the n x to the n. So we get the limit as n goes to infinity, absolute value, 2 to the n plus 1 over 2 to the n, that just gives us 2, and x to the n plus 1 over x to the n, that just gives us x. So we no longer have any n, so this is simply the absolute value of 2x, or 2 times the absolute value of x, because the absolute value of 2 is just 2. So remember, excuse me, the ratio test tells us that our series converges if the limit we get is less than 1. So converges if 2 times the absolute value of x is less than 1. Diverges if 2 times the absolute value of x is greater than 1. And we have no information if 2 times the absolute value of x is equal to 1. So let's see what these conditions tell us. So 2 times the absolute value of x less than 1 is the same thing as saying absolute value of x less than a half. So now I'll go back up to our number line and we see, okay, absolute value of x less than a half. That means we're in between minus a half and a half. So we know our series converges inside this region. We know we diverge outside this region. So we diverge when the absolute value of x is greater than a half. And we don't know what happens at the endpoints plus or minus a half. So we need to figure out what's going on here. But we can tell already from this first bit that our radius of convergence is equal to 1/2. So our interval goes 1/2 on either side of 0. So now to get the interval of convergence, we need to check the endpoints. So we need to say, okay, what happens if x is equal to a half? So if x is equal to a half, we get sum n equals 0 to infinity. Just plugging in x is a half, we get 2 to the n times 1/2 to the n. So this just becomes sum n equals 0 to infinity, 1 to the n, or just 1, 1 plus 1 plus 1, etc. This series clearly diverges by the test for divergence. So I'll go to my number line and I'll go up and say, okay, at x equals a half, I can cross out that question mark and put in a diverges. So at x is a half, we diverge. Now let's see what happens at x is negative a half. So at x is negative 1/2, again, just plugging in x equals negative a half, we get 2 to the n times minus 1/2 to the n. 2 times a half is minus 1, so we get minus 1 to the n. Notice that the limit as n goes to infinity of minus 1 to the n does not exist. So again, this series diverges by the test for divergence. So at x equals a half, our series diverges. At x equals minus a half, our series diverges. So again, I'll cross out this question mark and put in a diverges. So our radius of convergence was a half. We diverge at both endpoints, which tells us our interval of convergence is just minus a half to a half. So the open interval on both endpoints, minus a half to a half. So radius of convergence 1/2, interval of convergence, open interval minus a half to a half. Neither endpoint is included in the interval.